Mole concept from grade 11. The first thing that you need to know is what is a mole. So whenever you hear the word mole, when you hear the word dozen, that is D-O-Z-E-N, what does that mean to you? It means 12, right? So whenever you hear the word mole, you should remember the number 6.022 into 10 raised to 23. By now you must know what this number is. This number is called as the Avogadro's number. It is represented as capital A with a subscript, capital N with a subscript small a. So 1 mole is equal to 6.022 into 10 raised to 23. You should by heart this formula because it is useful for all the things that we will be going through today. And this is called as Avogadro's number, represented as Na. The next thing that you need to know to solve all the questions are the atomic mass units of some elements. So what is an atomic mass unit? The atomic mass of an element is the mass of one atom of the element. So suppose you have an element and you know elements are consisting of so many atoms. The mass of one atom is called as atomic mass unit. And we know the atomic mass units of so many elements. But we luckily only need to study a few. And they are hydrogen, carbon, nitrogen, oxygen, sodium, magnesium, sulfur, chlorine and calcium. So you need to know all the atomic mass units of these elements. So hydrogen, as always, 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, sulfur will then be equal to 32, chlorine 35.5 and calcium 40. So try to memorize all of this and come up with tricks that you can understand or keep in mind to know these. You need to know this. Why? Why do you need to know this? For example, if they give H2O and they ask you to find the molar mass, that is something we will be learning later. How do you find the molar mass? H. So how many H is there? 2H, that is 1. So 2H, that is 2H into 1. Plus, when we add all the atomic mass units of the compound, we'll get the molar mass. Oxygen is 16. So 2 into 1, that is 2. 2 plus 16 is 18. So 18 AMU. This is how we'll be finding so many molar masses of many compounds that will help us definitely to go through all the questions that we do. Now let's look at the value of the number of moles. The number of moles of a element is represented as small n. Okay, so the number of moles is represented as small n. N, the formula for n is mass, that is given mass divided by molar mass. Given mass, it will always be given in the question. And molar mass, how do we find the molar mass? Using the atomic mass units. That's why I said you need to know this to go through all the questions that we'll be looking. So this is another formula that you need to keep in mind. N is equal to m by m. We can also derive the equation for molar mass as well as the given mass. Suppose in your question the given mass is unfortunately not given. How do you find it? Then m will be equal to, whenever the numerator goes to this side, n and this will be multiplied, which is equal to n into the molar mass. This is how you find the given mass. Now if the molar mass is not given and if you're too lazy to do all of this, then you can do molar mass is equal to mass divided by n. N is number of moles. So these are the side equations that you need to remember with this. If you know this, this will automatically come to your mind. So this is the value of number of moles and this is important as well. So this is the first formula for the value of number of moles. And there are many formulas for finding number of moles in different situations. This is when the weight or the mass of a compound or an element is given, and if it is not given and instead the number of atoms, that is all, like in an element, as I said, there will be so many atoms, right? If they give the number of atoms, then the number of moles will be equal to, or the number of atoms will be equal to number of moles into 6.022 into 10 raised to 23, or number of moles is equal to, or N, that is number of atoms, N is equal to number of moles into Na. This is Avogadro's number. So N into Na, this is another formula. Now if they give the volume, then the number of moles is equal to the given volume divided by 22.4. These are again important equations, but the most important one is this. Now let's go through each of the equations, starting with mass percentage. So what is mass percentage? Mass percentage, as the name suggests, mass, the percentage of the mass. So the mass percentage is equal to mass of the solute divided by total mass of the solution. Mass of the solute, that is the given solute, its mass divided by the total mass of the solute and the solvent. We know solute plus solvent will be equal to the solution. So yeah, whenever you see percentage, multiply it with 100. This is the equation for mass percentage. If you're having doubts with this kind of equations, when you practice more and more questions, this will be more easier for you, and we'll be doing that lately. If this is the equation for mass percentage, then what will be the equation for volume percentage? Just like this, volume percentage is equal to volume of the solute divided by total volume of solution. And again, when percentage is given, multiply this with 100. So this is the equation for volume percentage. Whenever mass comes, there will be mass and mass at the numerator as well as the denominator. When volume comes, numerator, denominator, volume will be there. And do not forget into 100. This is really important. Next is W by V percentage. Now, this might frighten you at first, but W is represented as mass. V is volume. So this means mass by volume percentage. So what is mass by volume percentage? Mass by volume percentage is equal to, again, mass of solute divided by total volume of solution. So just take volume. What is the denominator of volume percentage? Total volume of solution. What is the numerator of mass percentage? Mass of solute. So mass of solute divided by total volume of solution. And again, percentage is given, so into 100. This is another equation that you need to know. The next thing is mole fraction. Mole fraction is really easy if you understand how to do this. Okay, if the questionnaire or the one who makes the question paper gives you or asks you to find the number of moles or the mole fraction of a compound A, then the mole fraction will be equal to Na divided by Na plus Nb. That is number of moles of the solute divided by the total number of moles of the solution. Solute plus solvent is equal to solution. So solute is Na, solvent is Nb. So when you add this together, you get solution. That is, the mole fraction is equal to the number of moles of solute divided by the number of moles of solvent, or plus the number of moles of solute, that is number of moles of solution. If they ask you to find the mole fraction of the compound B, just like this, Nb divided by Na plus Nb. It's that simple. Just get the logic of this. So this is all about mole fraction, and mole fraction is very, very important in this chapter as most of the questions will be coming from mole fraction. Another important, and let's say the most important ones, are mole fraction and then molarity. What is molarity? Molarity is nothing but, molarity is represented as capital M. Molarity is the moles of solute, that is the moles of solute divided by volume of solution in liters. Okay, so the moles or the number of moles of solute divided by the volume of the solution. Now remember molarity, this is R. Okay, remember this. I'll tell you why you should remember that it is R. Why remember molarity is with R? Because then we have another term called molality with an L. And molality is represented as small m. Over here, small m. Now what's the equation for molality? The number of moles of solute divided by mass of solvent in kg. So this is what you need to remember. Over here when you look, molarity, when R comes or when they ask for molarity, always they'll ask for, always remember liter. R is equal to liter and volume. Okay, liter will be counted as volume. So R is liter. And when you look here, molality with an L, it will always be kg or the mass. So whenever, this is a trick to understand the difference between molarity and lity. Whenever R comes, always it is L. R is not molality. L is for kg, R is for liter. This is what you need to remember, so it will be easy for you to distinguish. Again, molality, mole fraction and molarity is very important for this questions. An important conversion that you need to remember is 1 ml is equal to 1 by 1000 liters. So to convert milliliter to liter, the equation is 1 by 1000. And 1 kg is equal to 1 by 1000. 1 gram is equal to 1 by 1000 kilograms. Why did I say this? This is needed for molarity. This is needed for molality. R and L. Then what you need to know is, whenever in a question they tell 10% of aqueous solution by mass. When they give 10% and by mass, it always means that 10 gram is what they meant. When they give 10% by mass, it is 10 grams. And whenever they tell 10% in water or in any solution, that means they're implying that 10% is milliliter, 10 milliliter. If you remember these important concepts, then whenever you see a question, you won't have to think more. This will come very easily for you. Now let's do a few questions on all of this. And before that, the most important or another final equation that you need to know is the equation of dilution. And the equation of dilution is M1 V1 is equal to M2 V2. This can be used to find any of the components by rearranging the letters or the values. So these are the equations that you need to know throughout the mole concepts. Next, let's do a few questions, and the questions will be in another video, and don't worry, it will be right there after this video. And if this video helped you thus far, please like and subscribe to this channel. And yes, go to the next video. Thank you for watching.